Good morning, students. Good morning to all of you. Okay, today's topic is electric potential and potential difference. Okay, what is electric potential? Let us see here. Suppose we know that charge is having properties to attract another charge or repel another charge. It's having a property. Charge is having property. Then how the charges are attract another charge? Let us see here. Suppose there is a charge of plus q coulomb charge. There is a charge. And we know that if you bring another charge near it, it experiences some forces. Either it is an attractive form or it is in repulsive form. If you bring a positive charge, it will repel the positive charge, and if you brings a negative charge near it, it experiences of forces that is attractive in nature. Suppose how it experiences of forces. Let us say, suppose there is a boundary. We know that there is a boundary or there is a region around it. There is a region or a field around it, and this field is known as electric field of that charge. If you bring another charge, and suppose there is a 2 coulomb charge, if you bring another charge in its boundary, this region is a boundary or this region is a field of that charge, that is called electric field. This region is called electric field of plus q coulomb charge. And if you bring another charge of same nature in this or its boundary or its electric field, it experiences some forces in outward direction. As you bring, if you bring this charge into its boundary, it experiences some forces. This force is called electric force. Okay, and in electric potential concept, in electric potential, what the electric potential says that if you bring a unit positive charge, from infinity beyond the boundary or beyond this region, there is an infinity. Beyond the boundary or beyond this electric field, there is a called infinity. And according to definition of the potential, if you bring a unit positive charge from infinity to a given point, if you bring a unit positive charge from infinity to a given point, that is P, you will do a work. Because how you do a work? Because this charge will repel this charge, and you have to work against this force. The q charge will repel this charge, and you have to do a work against this electric force. This work is stored in the form of potential. Okay, I think up to which you will able to follow me here. Suppose according to the definition of the potential, if you bring a unit positive charge from infinity, this point is called infinity because it is beyond the boundary or beyond the electric field. If you bring a unit positive charge, unit means 1 coulomb, and positive means its nature is positive. If you bring a unit positive charge from infinity to a given point, you will do a work because a force is acting towards outside. Because you bringing a positive charge and here also a positive charge, this positive charge will repel this positive charge. Then you have to do some work to bring from infinity to a given point. This work done is stored in the form of potential. Okay, I think you are able to follow me. So here a potential will develop because you have done some work. As you learn in class 9th that if you a massive body, if you do a work to bring this mass from 0 level of height, from ground to h height, this work is stored in the form of gravitational potential energy, that is called PE in mgh form. If the mass is to be raised up to a height h, then there is a work you have to do. This work against the gravity is called gravitational potential energy. In the same way, if you do a work against the electric force, this work is stored in the form of electric potential. I think up to which you are able to follow me. Here, what is the formula will form in electric potential? Suppose one thing you have to learn here, that suppose you are bringing a plus 1 coulomb charge from infinity to a given point. This work is done, is stored in the form potential, and again you want to put this positive charge from infinity to a given point P, and again you want to put this positive charge from P to point S. What will do? You have to do again further some extra force or extra work you have to do from put this plus 1 unit charge from point P to S. From point P to S you have to do an extra work. This work done is greater than this work done. This work done is greater. This work done, suppose this work done is W1, okay, and this work done is W2, okay. I think you are able to follow me. Then the W2 will be greater than W1, okay, or you know that this work done is stored in the form of potential, you say as a V1, that is potential, and you will do an extra work, that is W2. This work done you have to do, W2 will be greater than W1, and this work that is stored in the form of V2, and the V2 minus V1 will gives the potential difference. What is the difference between this potential? This one V2 and this one V1. This potential becomes V2 minus V1, or the W2 minus W1, because the difference between the potential is called the potential difference. I think you are able to follow me up to it, okay. Here according to the definition of the potential, you see that potential is defined as, here you write the potential or the electric potential. The electric potential is defined as to bring the plus 1 coulomb charge from infinity to a given point in the electric field. We will do a work this work done is stored in the form of electric potential. I think you are able to follow up to which, okay. Again, then according to the definition, what the formula comes, the work done to bring Q charge, the work done per unit charge, will gives the potential or potential difference, okay. I think it is clear up to which the formula will come that V equal to W upon Q. Here W is work done by external agent. You will do a work, then you are external agent, and the Q is charge, okay, and this was potential. Okay, I think it is clear up to which. Then what is the potential difference? Potential difference means what? If you do a work in a unit positive charge from bringing this charge from point P to Q, then it will give the potential difference. This one called potential, this one called electric potential, okay. And what is electric potential difference or potential difference? Electric potential difference. Here you see, if you do an extra work to bring this charge from point to S, from point P to S, then the extra work done is stored in the form of potential difference. You can write that to bring plus 1 coulomb charge from point P to S, from point P to S, this work done is called potential difference. This work done is called potential difference. Or we can say that the difference between the potential between 2 points, from here a difference here, from here it is a potential of V1, and from here to here the potential of V2, then we say that the difference in potential between 2 points is called potential difference. Also you can say the difference in potential, the difference in potential between 2 points, in electric field, is called potential difference. I think it is clear up to which. Okay. Then a question arises that what is unit of volt? The SI unit, here you can write the SI unit of potential or potential difference is volt, denoted by V. Okay, the SI unit of potential is denoted by V. And a question is here, what is 1 volt? Okay, what is 1 volt? A question is here, what is 1 volt? What is 1 volt? You see the answer of this question, what is 1 volt? As you learn that a formula of a volt or a potential difference or potential is equal to W upon Q, work done per unit charge is called potential. As the SI unit of work is joule, the SI unit of work is joule. Okay, the SI unit of work is joule, and the SI unit of coulomb or charge is coulomb. Okay, then you will gain that 1 volt, the SI unit of voltage potential is 1 volt, or volt, the SI unit of potential is volt. Then 1 volt becomes 1 joule per 1 coulomb. It means that if you bring a 1 coulomb of charge from infinity to a given point, if you bring a 1 coulomb of charge from infinity to a given point and you will do a work of 1 joule, then a potential difference of potential will stored in the form of 1 volt only. Okay, here you can write, if you bring a 1 coulomb of charge, positive 1 coulomb of charge, or a 1 coulomb charge, if you bring a 1 coulomb of charge, from infinity to a given point, and you do a work of 1 joule, then a potential will stored, and then a potential will stored that is 1 volt. Okay, I think it is clear. If you bring a 1 coulomb of charge from infinity to a given point in the electric field, here you write here in electric field. Okay, in electric field, and you do a work of 1 joule when you bring a 1 coulomb of charge from infinity to a given point in electric field, and you do a work of 1 joule, then there is a potential of 1 volt. You can write, then a potential will stored, that is 1 volt. Okay, I think it is clear. Okay, so now this topic is over, electric potential and potential difference. Okay, I hope you are able to follow me. Okay, thank you very much.